All right, you guys. So now what we're going to do is we're going to determine if triangles are congruent based on what is given to us. Now, sometimes what is marked in our picture is not enough to show that all three sides and all three angles are congruent. Okay, so there are two things that we're allowed to mark in our diagram in addition to what we're already given to show that other angles and sides are congruent. And this will help us to mark sides and angles that we don't know are congruent to be congruent. So that way we can help prove that these triangles are congruent. Okay, so these things will save us when we have those angles and segments that are not marked congruent. These tricks up our sleeve could help us mark additional angles and segments congruent, which will then show that our triangles are congruent, which we're really hoping they are because we like when things are congruent. Guys, so the first trick up our sleeve is the reflexive property. Now, what does the word reflexive kind of sound like? It does kind of sound like the word reflection. Okay, so when you see a reflection, you see yourself. So the reflexive property is when a statement, or an angle technically, is congruent to itself. Now you're probably like, Miss Long, why would I say that a congruent or segment is congruent to itself? That is the most absurd thing I think I've ever heard. Well, I thought the same thing too until I found out the wonderful things that the reflexive property will do for us. Guys, so let's say I have this big triangle. Do you see in the big triangle there are two smaller triangles? Okay, in each of these smaller triangles, they both contain side AB. This triangle has side AB, and this triangle has side AB. Okay, so since each of these triangles have a shared side, this side might not be marked congruent in my picture. Okay, so then I could mark in this side as congruent because each triangle shares that side, which means that that side has to be congruent because it's congruent to itself. Okay, so AB will be congruent to itself, which that will help me to obtain one more side, in this case it's a side, one more side that is congruent that I didn't already have. So the reflexive property is really going to be a lifesaver at times. The second trick up our sleeve that we're going to talk about is the vertical angle theorem, which we have talked about this. Okay, how do we spot vertical angles? What letter do we see when vertical angles appear? We do see a nifty X shape. Do you see in these two triangles how there's this lovely X right here? Whoa, which means there are vertical angles right across from each other. And the vertical angle theorem tells us that vertical angles are in fact congruent. Okay, so if our vertical angles are not marked in as congruent in our picture, that could also be something that we can mark in our picture to help show that one more pair of angles is congruent. Because the goal is to show all three angles and all three sides are congruent. So just be careful. So in this case, angle ABC is congruent to angle DBE. Now, there's actually one more thing we can, it's not really marking something in our picture, but one more trick up our sleeve will help us to show that additional angles are congruent. So let's say I have these two triangles. I know that they each have a 35-degree angle, and they each have an 88-degree angle. So two of the angles in each of these triangles are congruent. Okay, so I need to figure out if the third angle in my triangle is congruent. Okay, well, what do all the angles in a triangle add up to equal? They do have to be 180. So to find the third angle in my triangle, I can add 88 to 35 and subtract that from 180 and I'd get 57. Which if you guys see here, since both of these triangles have an 88 and 35, when I add those up and subtract from 180, both times I'm going to get 57. Whoa, right? Okay, so if I know that two angles in my triangle are congruent by the third angle theorem, I like to say it with a country accent, third angle theorem, by the third angle theorem, we will know that the last or final, or in this case third angles, are congruent. Okay, so if we know two of the angles in our triangles are congruent, I can mark the third angle as congruent by the third angle theorem. So that will also be a lifesaver at times. Okay, so now we're going to be working on example 2, 3, 4, and 5. Right now, I'm going to show you how to do example 2. So what we're going to do, we are going to determine if there is enough information given to determine if the figures are congruent. So I want to know if my two triangles are congruent, which the way we do that, we must show that all three sides are congruent and all three angles are congruent. And if we can show all three sides and all three angles are congruent, then we're going to write a triangle congruency statement. Okay, so if you'd like to copy down example 2, you can copy it down from here. But I'm going to go ahead and get started on example 2. So let's get going on example 2. It's going to be a blast. Okay, so I must show all three angles. Sorry, all three sides, read Miss Long, all three sides and all three angles are congruent, okay? And if I can do that, I'm going to write a triangle congruency statement. Okay, so I'm going to start with the sides, okay, which remember the way that we mark congruent sides are by these little tick marks on the segment, okay, which the sides that are congruent have the same number of tick marks. So do you spot any sides in my two triangles that are congruent? Which before we do that, you guys, just know if my picture does not say drawn to scale, which it doesn't, I can't assume anything about my picture. So even though it doesn't really look like my triangles are congruent based on how I drew my picture, I can't assume anything because I did not say drawn to scale. So just keep that in mind. Anyway, so what is one pair of congruent sides? Well, I see that there's one tick mark on these two segments, which means they are congruent. Okay, so I'm going to say segment DC is congruent, DC, to CB because they each have one tick mark. Yay. Okay, and we're going to be writing how we know this. It's good to explain yourself, especially when we start doing proofs on these things. This will get us into the habit of explaining what we are doing. Okay, now, since I was given that these two are congruent, it was marked in my picture, I'm going to call it the given. It was given to me in my picture. Okay, do you spot any other sides that are congruent in the picture? Holy hot dog, you guys. Segment AC and CE both have two tick marks on the segment. So I can say AC is congruent to CE. And also, you guys, since I was given this, or they showed it to me in my picture that they are congruent, the reason would be because they are given. All right, do you spot any other sides that are congruent? Indeed, you guys, indeed. I can say AB has three tick marks, and DE also has three tick marks. So AB is congruent to DE. And also, since it was marked in my picture, the reason would be it was given to me. Okay, so I have three sides that are congruent. Yes. We're well on our way. I got three sides. Now I need to prove three angles are congruent. And if so, my triangles are congruent. Okay, let's see what happens. So currently, do you see any congruent angles already marked or given to us in the picture? Oh man, you guys, yes, it would be angle A and angle E. They both each have one arc drawn on them, which means they are congruent. So I can say angle A is congruent to angle E. And again, it was in my picture already, so this is also the given. So I got one side, yes, or one angle. All right, so I don't have any more angles. Oh no. Does this mean my triangles are congruent? Well, not quite, not quite. Hold your horses, you guys. Okay, so do you see of any of those tricks up our sleeve that we talked about that we can mark in our picture? We can mark in a shared side or angle by the reflexive property. We can mark in some vertical angles as congruent if we see any X's in our picture. And then if we know two of the angles in our picture are congruent, by the third angle theorem, we can show that the final angles are congruent. So do you guys spot any of those things, any of those tricks up our sleeves that would allow me to mark in another congruent angle? Oh man, you guys are on it today. Okay, do you guys see right here? What letter do we see? Do you guys see the X? Oh, man. Guys, that means I have spotted vertical angles. And vertical angles, you guys, are congruent. So I'm going to mark those in my picture. All right, so these two angles are congruent, which to differentiate them from the other two, I'm going to add another arc. Okay? Now, in here, I cannot call these angles C because angle C has more than one angle. We can only call them by their vertex if they only have one angle there. Like angle A only has one angle. Angle C has two angles. It actually technically has four, but so that does not allow me to call it angle C. So I'm going to call this first angle. I kind of trace the angle and name it as I go. So that'd be angle ACB, or you could call it BCA, whatever floats your boat. So angle ACB is congruent to angle DCE or ECD. So I'm going to call it angle DCE. And how I know that is because they're vertical angles. So by the vertical angle theorem, I know those two are congruent. So I have two angles congruent. Oh, man. We're getting closer. You guys. Okay. So I'm going to need one of those tricks up my sleeve. So I know that two angles are marked congruent. Okay, so if I know two of the angles are congruent, does that mean the last or final or third angle is congruent? Yes, it does. And the reason why is because if I know two angles are congruent, the third angle theorem tells us the last ones or the third angle has to be congruent. So I know that angle B, which it's a different angle, so I'm going to put an extra arc, angle B is congruent to angle D. And that would be because the third angle theorem. So angle B is congruent to angle D by, that's a D, sorry guys, by the third angle theorem. There you guys say it. Your best southern accent. Third angle theorem. That's the best I can do, you guys. All right, which I have shown three sides and three angles are congruent, which means my triangles are congruent. Now, we're not going to write like 5 different triangle congruency statements. We just don't have time for that, okay? We ain't got time for that, so we're going to move on. So we're just going to write one congruency statement, which it doesn't matter how you name it. So you can name the top triangle using any of the 3 vertex points in any order that you want. Okay, so to keep it simple, I'm just going to call it ABC. So I'm going to say triangle ABC. I'll keep it in green. Triangle ABC is congruent to triangle. Now, the way I know how to write my next statement, remember, triangle congruency statements have to show their corresponding parts. So I like to trace my triangle and kind of take note of markings I see to help me with my other triangle. So if I go from A to B to C, if I'm looking at my tick marks, I see 3 tick marks on the segment. Then I see 1 tick mark. Then I see 2. So when I trace this one, I need to see 3 tick marks to 1 tick mark to 2 tick marks. So 3 to 1 to 2. So if you see here, if I start at E, I pass 3 tick marks here, then 1 tick mark, then 2. So the correct way to name this triangle is triangle EDC. Also, you guys, since we know like A and E are congruent, they should be in the same spot. We also know B and D should be congruent, so they're also in the same spot. So that could also help you. My A and E are both in position 1, and then my B and my D are both in position 2. And then C is a little ambiguous because there's a lot going on. But that's another way you can kind of line up your triangles to help you see how to write your triangle congruency statement. Well, guess what, you guys? We are done with example 1, and if you heard the bell, my next class is coming. So I'm going to have to say goodbye, you guys. Ciao, ciao.